Hello everyone. So today we will see the gravitation chapter after a few days. So this is a part of physics also. So why we will study the gravitation. तो उसका फायदा क्या है हम इस चैप्टर में देखेंगे. तो इसमें होता क्या है. So what we will study? We will study the gravitational force. What is the gravitational force? And what are the properties, and some more idea about the value of g, and the value of g at a height and at a depth. Then we'll discuss the orbital velocity. So what is the orbital velocity? And then the escape velocity. So this is the orbital velocity and the escape velocity. We'll discuss that one. Then we'll lastly in the last we'll discuss about the Kepler's laws. Okay, so that these are the things we will cover. So first of all thing, why we will study the gravitation, where we can find this gravitation or where we can feel this gravitation. तो हम इसको कहाँ feel कर सकते. Okay, so first of all, why we will study the gravitation? Because we already know that we are in the situation that in the hanging situation. तो हम लोग मतलब ऐसा जो मतलब हमारा प्लानेट अर्थ सिस्टम है, तो हम सब क्या करते हैं, मतलब कोई उसके ऊपर खड़ा है तो कोई नीचे ऐसे पोजीशन में है, तो कि छिड़ा भी है ताकि झुलिकी भी अच्छी, तो अर्थ भी रोटेट करुची जोटा कि सन चारिपटे. तो सन को आम गोटे जब स्टार कंसीडर करवा, if we consider sun as a star, then the earth is rotating about its path, its own path, and in the path of the sun. That is the orbital path. Okay, so this is the orbital path. So earth is rotating around the sun. Okay, so if we feel that if you drop this chalk or if you drop anything, it will comes towards the earth center, right? So there is something, that means there is some gravity which acts us, that means which pull us to downward. Okay, so gravitational एमती गोटे जिनस रोचे जोटा कि आमको अर्थ आड़ को टाणी रखुचे. तो सहीटा आम फिल करें जेकोसी जिनस को जब आम ड्रप करवा ताहले से अर्थ सेंटर आड़ को अट्राक्शन होके आसुचे. तो किए गोटे निहाती रूप में टाणुचे, तो किए गोटे फोर्स माने अट्राक्टिव फोर्स के गोटे पड़ुची, तो जार ना हो ग्राविटेशनल फोर्स. सो आम कहीं ग्राविटेशनल फोर्स पढ़ा कहीं because in every system, that means in our outside in चतुर्पार्श्व. So जो जिनसटा भी हमें देखिबा, all everything which has a mass, that massive object is attracted by a gravitational force. Okay, so gravity is the properties. Gravity is a properties. Okay, so gravity is a properties. So it is an attractive property and it attracts every massive object. Okay, so it is a attractive property. It is an attractive property, right? And the second thing, it attracts towards the center. It attracts towards the center. Towards the center. Okay, so it is an attractive property and it attracts towards the center of the earth. Center of the earth. Okay. तो এটা कहाँ पर पड़ुचे? So it always acts on massive object. Okay, massive object. So जहाँ भी mass रोचे, तो सही को आमर ग्राविटी जो प्रॉपर्टीज ताको अट्रैक्ट करुचे एवरी ऑब्जेक्ट को, राइट? सो तो मेन जिनस होचे जे एवरी मैसिव ऑब्जेक्ट इज अट्रैक्ट by a properties, that by a characteristic, that is the gravity. Okay, so what is gravity? So it is an attractive property. It is an attractive property and it attracts every massive object towards its center. So you can feel that Earth is rotating around the sun. So some satellites also rotating around the Earth, like the BSNL, Airtel. We have some network systems. They have their own satellites. So the satellites are revolving also around the Earth. Okay, so Earth also revolving around the sun. So every system is revolving its own path, and its planet path, and its satellites path, and its orbital path by the action of the gravity. Okay, so every massive object has a gravity. But remember, the gravity's property is always attractive towards its center. That means if we will move to upward, what will be the gravity action? If we will move to downward, what will be the gravity action? So that things will cover about the value of the G. Okay, so gravity is a properties, but the fact which one is attract, that means the force, which force is attracting force. So that is known as the gravitational force. Okay, so gravitational force is a force that is a vector quantity. So it has magnitude and it has also dimension. So we'll discuss the Newton's law of gravitational, what Newton's give about the laws for the gravitational. So and we will discuss about the gravitational force. Okay, so why we will discuss gravitational force? Because everyone is attracted by the Earth's gravitational pull. Okay, by the Earth gravitational pull. By a force known as gravitational force. So gravitational force is a attractive force. Okay, it is strong or weak, we will discuss later. But gravitational force is a attractive force which action is to pull every massive object towards Earth center. Okay, so you can write also what is the gravitational force. So it is an attractive force, and it attracts every massive object towards the center of the Earth. Okay, so we will write the properties of the gravitational force. But first of all, we have to know that the gravitational force is an attractive force or repulsive force. We have to know this one. Okay, so now we will see the gravitational force. So what is the gravitational force? Or Newton's law of gravitation. So you can say it's the Newton's law also. Newton's law of gravitation. What is Newton's law of gravitation? You can write the theory also. What is the Newton's law of gravitation? But I will explain you what is the Newton's law of gravitation. So what Newton's law says that two massive object, if that means if m1 is the mass and m2 is another mass, if m1 is mass and m2 is a mass, and remember one is heavier mass and another is comparatively lower than that of the second mass. So that m1 and m2 they are separated by a distance r. Then if two massive objects having mass m1 and m2 are separated by a distance r, then there will be a force of attraction between them, between the two massive objects, and that force is known as gravitational force. And Newton says that the gravitational force is proportional to mass of the first object, is proportional to mass of the second object, and is inversely proportional to square of the distance between them. So this is the Newton's law of gravitation. The attractive force, that means the attractive force between two massive objects is directly proportional to their masses and is inversely proportional to square of the distance between them. Okay, so this is the Newton's law of gravitation. So two massive objects attract each other by a force known as gravitational force, is proportional to their masses and is inversely proportional to square of the distance between them. So this is the Newton's law of gravitation. Then what we will see that if we will use the mathematics, then that all are equal to be, that is proportional to m1 m2 divided by r square. Okay, so this is proportional to m1 m2 by r square. Then that will be, if you will leave the proportionality, then you have to add a constant, This is known as gravitational constant. Okay, so this is gravitational constant, and the value of the G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, Newton meter square per kg square. So this is the value of the gravitational constant, because G, what will be the expression for G? So G is nothing but Fr square divided by m1 m2. So what is the unit? Newton meter square divided by kg into kg. So Newton meter square divided by kg square. So this is the value of the gravitational constant. Okay, why there is a negative sign, and what does this negative sign means? Why this is minus 11? Okay, so m1 m2 is the masses of the two massive objects, and r is the distance between them. If you will see that someone is situating above the earth, so this mass is m1, this mass is m2. Okay, and let there be some, this is central force, right? So the separation between them is r, because we know that the mass of the earth is concentrated in the center. A spherical object, the mass is concentrated at the center. Okay, so that the difference, the distance between them is r. Remember, this is you, this is the position of the object, and this is a small object in comparison to earth mass. This mass is compared to, if you compare to the earth mass, then this is very low. Okay, remember, this r is the central distance. Remember, r is the central distance. This is very important. Distance is the central distance. Okay, central distance. Central रो हमको नबाको पड़िबो. एठी नो जे एठी बसते ता पर माने distance is 0. So this is the central distance. Okay, and m1 m2 are the mass. Then we know that the unit will be Newton meter square per kg square, and if you find the dimension, that is also important. So the dimension of G, what will be the dimension of G? So that is force, so that is ml t minus 2, then we multiply with the distance square, so that is l square divided by, and the mass square, so that is m2. So the dimension finally come out l minus 1, l3 and t minus 2. So this is the dimension of the gravitational constant. This is also important. This will ask in your exam. So what is the unit and what is the dimension of the gravitational constant? Okay, so what is Newton's law? The force of attraction between two massive objects is directly proportional to product of their masses, and is inversely proportional to square of the distance, square of the central distance between them. Okay, r is the central distance. So this is the gravitational force. Then what is the properties of the gravitational force? What are the properties between the gravitational force? So to explain, that is to understand the properties of gravitational force, I'm taking to you a short thing. So try to understand what I am going to say. So the most important thing is, that means the explanation is that, suppose you remember, you consider that this is the earth and you are situating above the, remember the earth is rotating, right? The earth is rotating. So we have two cases. One may be at the top end, one may be at the down end. Okay, तो जड़े ऊपर अच्छे और जड़े तले अच्छे. तो सिचुएशन कौन हो चे ना एक केस रे देखा. So in this case the weight is to downward. Okay, so the weight is to downward, and the gravitational force is a attractive force, and it acts always towards the center. So this is the gravitational force. Gravitational force सब बेले center आड़े को पड़िबो, किंतु weight टा तो तोड़ को पड़ुचे. तेनु weight gravitation एटी balance होउचंती. तेनु जो object, so this object will be in the rest position. The gravitational force always act towards the center. Remember, the gravitational force, it is a vector quantity, right? So So the magnitude is g m1 m2 divided by r square, and the direction is towards the center. Towards center. Okay. So this is towards the center. The gravitational force is always towards the center. So this case we can understand. But look to this case. What's happening in this case? Okay. So in this case, the Earth is rotating, right? The Earth is always rotating. So this is a Earth. So this also a Earth. So in this case, what's happening? Our weight is downward, right? Our weight is down. Then our gravitational force also downward. Gravitational force भी तलको पड़ुचे, weight भी तलको पड़ुचे, ताहले situation कौन होगा कथा जे ऑब्जेक्ट टा अर्थ भीतर को पसी जागा कथा है ना नहीं जदि हमें देखिबा मैथमेटिकली सो वेट और ग्रेविटेशनल फोर्स दुईटा जाको ए फर्स्ट केस रे केस 1 रे दुईटा जाको कोन होचे ना तलको आसुचंती ओके ग्रेविटेशनल फोर्स भी तलको वेट फोर्स भी तलको तेनो एठी कोन होबा कथा एठी एमाने पुल हिजबा कथा बुझेला किंतु मन रखि था एठी केस आसुची गोटेला सेंट्रीपेटल फोर्स आ गोटेला सेंट्रीफ्यूगल फोर्स दुईटा केस आसुची सेंट्रीपेटल फोर्स and the another one is your centrifugal force. Centrifugal force. Remember the centrifugal force is mv square by r. Okay. Sometimes that this one write as m r omega square also. So this is the value of the centrifugal force. And remember this is a centrifugal force always act towards the center. It is towards center. But this is outward center, outward center. Okay, so centripetal force जोटा सेटा सेंटर आड़ को पड़े आ सेंट्रीफ्यूगल फोर्स सेंटर रु आउटवर्ड तेनु जितबेले कोनोसी गोटे सिस्टम रोटेशनल मोशन करथाय तेनु ता ऊपर सेंट्रीपेटल फोर्स पड़े आ सेंट्रीफ्यूगल फोर्स भी पड़े ओके तेनु एठी हमरो गोटे रहिला सेंट्रीफ्यूगल फोर्स ओके सेंट्रीफ्यूगल फोर्स इस सेंट्रीफ्यूगल फोर्स रा एक्सप्रेशन कहते ना mv स्क्वायर बाय r ओके सो अर्थ जो स्पीड रे रोटेट करूचे तार रेडियस तार मास जदि हम एठी यूज करबा ताला हम सेंट्रीफ्यूगल फोर्स पाइबा सो सेंट्रीफ्यूगल फोर्स ता हम एठी एक्ट करूचे किंतु एठी कोन रहउचे ग्रेविटेशनल फोर्स रहउचे वेट फोर्स भी रहउचे ता माने दुईटा जाको मिसी करी अछंती तेनु ये ऑब्जेक्ट को भीतर को टानी आनिबा कथा किंतु प्रॉब्लम होउचे कोन ना ग्रेविटेशनल फोर्स इज ए वीक फोर्स ओके ग्रेविटेशनल फोर्स इज ए वीक फोर्स so remember so this is a weak force first of all thing this is a weak force okay and this is a centripetal force kahi na eta center adu ko paduche so this is a centripetal force and third thing it is short range okay so it has some range short range that means ame jodi हमर जेमति कहूचे कि हमर 1600 किलोमीटर पर्यंत इस माने किछि एरिया पर्यंत हमर अर्थ ग्रेविटेशनल पुल अछि ता बाहर को जदि हमें पळेबा ताहले अर्थ हमको आउ टाणी पारिबो नाही ओके सो ताकू यूज करिकि हमें माने सब स्पेस स्टेशन गुड को सब फॉर्मेशन करिचे त हमें माने महाकाश को जाई पारुचे स्पेसक्राफ्ट थ्रू रे सो दीज आर सो दिस इज शॉर्ट रेंज फोर्स ओके एटा किछि बाट पर्यंत ही एक्ट करूचे ता ऊपर को जदि हमें पळेबा ताहले से आउ एक्ट करिबो नाही ओके सो रिमेंबर द प्रॉपर्टीज दिस इज अ वीक फोर्स this is a centripetal force कहीं कि ना ग्रेविटेशनल फोर्स टा सब बड़े सेंटर आड़ को पड़े अब सेंटर आड़ को जे पड़े सही फोर्स टा को हम कोन कहंती सेंट्रीपेटल फोर्स आ जे सेंटर रु दूरे की पड़े माने सेंटर रु आउटवर्ड हे जाय जदि हम गोटे जिंस को रोटेट करथबा ताल ताको जदि हम छाडी देबा से टेंजेंशियली आउटवर्ड हे जिवो कहीं कि ना हम सेंट्रीपेटल फोर्स देई कि ताको टानुथिले ताको घुरौथिले तो जतबे हम सेंट्रीपेटल फोर्स बंद कर देबा सेंट्रीफ्यूगल फोर्स टा बेसी हे जिवो तेनु पार्टिकल टा टेंजेंशियली पळेगो माने यू केस टा suppose we are rotating we are revolving this one with our own force that is towards the central force this is the centripetal so centripetal centrifugal centripetal एक दूसरे Up to that time these two forces are equal, then we can rotate it. When we remove the centripetal force, that is the centripetal force will be maximum, so the particle will flow out. Okay, so सेट particle टी सेठी बाहर को पड़ेगा, थ्रू आउट हो जिवो. तेणु ये गला सेंट्रिपेटल सेंट्रिफ्यूगल. तेणु आम एथुर जानिले कौन ना ग्रेविटेशनल फोर्स इज ए वीक फोर्स. कहीं वीक फोर्स कहीं ना केस 1 को देख, जदि ये स्ट्रॉन्ग फोर्स ही था वेट सहित मिसी था ताले ये ऑब्जेक्टटा आउ अर्थ सरफेस रे माने आमे जो एमती अर्थ सरफेस रे छिड़ा हिचे आमे आ छिड़ा ही पार न थांते भीतर को पसी जाई थांते. ओके, सो दैट्स व्हाई योर ग्रेविटेशनल फोर्स इज ए वीक फोर्स. ओके, and this is also the same, but here gravitational and weight force, these are balanced. So here remember, here weight force is your centrifugal force and centripetal force is your gravitational force, and this is a short range force. कहीं ना अल्प बाट पर्यंत पड़ुचे तो ता आग को जदि आमे जीवा ताले आ ग्रेविटी नथिबो. ओके, so this is the these are the application of gravitational force. So now we will find out the acceleration due to gravity. So what is acceleration due to gravity? What is acceleration due to gravity? Okay, so a पर्यंत हम पढ़िले कौन what are the things we have discussed. So we discuss about the gravity. What is gravity? First of all, we see what is gravity. So we saw gravity. Second thing, the gravitational force. What is the gravitational? Gravitation. अब यहाँ भीतर हमें कौन देखिले? Newton's law देखिले. The Newton's law and the gravitational force. Force, its property. Okay. So up to these things we have studied. So if we equal to G m1 m2 divided by r square. So r is the central distance. मन रखी था center रो distance. Outer surface रो नो center रो distance. And g रो value कहते हैं 6.67 into 10 to the power minus 11 Newton meter square by s square. अब यार हम डायमेंशन मध्य देखिले. सो एबे तुम माने जानि पारथबो एटी -11 काहे की रोचे, बिकॉज़ दिस इज द वीक फोर्स. ओके, so remember when electrostatic force is there also, because okay, so we will discuss electrostatic force later in this electrostatic topic. But remember, so these are the things. What is gravity? So this is the properties of attraction, and this is due to the gravitation. And which force is attractive? That is the gravitational force. And what is the expression of gravitational force? That Newton says by based on his theory, and this is the value of C. Then what is the acceleration due to gravity? Acceleration due to gravity. Okay, first of all thing, it is denoted by G, and we know the value of G is 9.8 meter by second square. So this is a acceleration. Okay, so this is a acceleration. But what type of acceleration? Again, we have seen now that if this is the earth surface, okay, if this is the earth surface, if we drop a object, right? So this is the object. So if you drop a object, then it is automatically moved to downward. It is automatically moved to downward. So with which acceleration it is moving, that is known as G, acceleration due to gravity. So acceleration due to gravity is the acceleration when an object is dropped from a certain height due to the action of the gravitational force. Okay, so acceleration due to gravity is an acceleration which acts on a object when it is dropped from a certain height due to the action of the gravitational force. Okay, so acceleration gravity टा होची गोटे acceleration जोटा गोटे पार्टिकल ऊपर पड़े, जेतबेले याको आमे गोटे हाइट रु छाड़ीबा ड्यू टू gravitational force. Okay, so acceleration due to gravity is the acceleration which act on an object which is dropped from a certain height h due to the action of gravitational force. So what is how you find the 9.8 meter per second square? Okay, if you will notice that if you will drop this object from a height h, if you will drop it, then it will come back to its earth surface and further it cannot move to downward. ଯଦି ଆମେ ଛାଡ଼ିଦେବା ତାହେଲେ ସେ ଆର୍ଥ ସର୍ଫେସରେ ରହିଯାଉଛି ଆଉ ତଳକୁ ଯାଉନାହିଁ। ତେଣୁ ସେଇ ସିଚୁଏସନକୁ ଆମେ ଦେଖିବା। ତ କେଉଁ ସିଚୁଏସନକୁ ଆମେ ଦେଖିବା ନା ଗୋଟେ ମ୍ୟାସିଭ୍ ଅବଜେକ୍ଟ ଅଛି ଯାହାର ମାସ୍ ହେଉଛି m. Let us consider an object which has mass m is situated on the earth surface. So earth surface and the mass of earth is m and the radius is r. So you know what is the relative mass of the earth. You can find it also in the Google. What is the mass of the earth and what is the radius of the earth. So these are the two constant things. Earth mass और radius एटा हमें सबटी नेट रू मध्य पाई परिबा. So that's not a big deal. So गोटे ऑब्जेक्ट अछि तार मास होछि स्मॉल m आउ अर्थ रो ऑब्जेक्ट अछि कैपिटल m. अब हमें सही सिचुएशन को देखु छे when the object is situated on the earth surface. So let us consider a object having mass m is situated is in rest position on the surface of the earth. Let capital M be the mass of the earth and capital R be the radius of the earth. So on this situation, okay, we have a gravitational force, right? And we have a weight force. So the gravitational force is okay. So if we look to this position, then that may be problem. Okay. So one more thing, the acceleration due to gravity, it has also both positive and negative side. When it is moving towards the earth, that means towards the earth center, then the value is minus g, and when it is outward, okay, so when it is outward, then in that case the acceleration due to gravity will be negative. When it is moving towards the center, positive. When it is moving outward, it will be negative. Okay, so this is the direction of the acceleration due to gravity. Okay, so when you are moving to upward, जेतବେଳେ तुम upward को move करा, so this a value will be minus g. जेतବେଳେ तुम माने down को move करा, downward को move करा, so that acceleration value will be g. So we have already seen it in our projectile motion. So जेतବେଳେ हम upward जिबा minus g, जेतବେଳେ downward जिबा हमर acceleration होगा plus g. Okay, so we are situated here. Okay, so we can still situate it. आम से पर्यंत रही पाइबा जेतବେଳେ हमर weight and gravitational force दुटा का balance हेतु. So what is the expression of weight? That is mg, and what is the gravitational force? So this is g m1 m2 divided by r square. So mm will be cancelled. Remember this is small m, mass of the object. So mm will be cancelled. So g is nothing but gm by r square. So you know the g value, and you can find out the m value, what is the mass of the earth and what is the radius of the earth. Then the expression of acceleration due to gravity is gm by r square. So you substitute the value of g here, and you tell me what is the mass of the earth in the comment section, and what is the radius of the earth. Then you substitute here, you will find out the value, that is 9.8 meter per second square. Remember, this is a free body system. That is, we are hanging, right? If you look to the case 2 case, so this is the earth, that is mass is capital M, and the object, this is mass is small m. So here is the gravitational force and here is the weight force. Okay, तेणु आम मैंने समस्त झुलिकी अच्छा तो केमी झुलिकी अच्छा ना वेट फोर्स आ ग्राविटेशनल फोर्स ये दुईटा जाक बालांस अच्छा तेणु वेट फोर्स एक्सप्रेशन है एम जी वेटा क्या जो पड़ुची ऑब्जेक्ट जो पड़ुची ना अर्थ जो पड़ुची ऑब्जेक्ट जो पड़ुची ना सो एम जी आटा सेंट्रल डिस्टेंस आटा capital R is our central distance. So if this is the earth radius, then this is also the radius. So this is the distance between the earth and us. So you can clearly draw this. So this is the earth, it has radius r and mass m, one is situated below. So this mass is small m. So this is the object, right? So the weight force is downward and the gravitational force is upward. This is the gravitational force. But what is r? R is the central distance. This distance also capital R. That's why that is g m1 m2 by r square. Okay, m1 is the small mass and m2 is the capital mass. So this is the acceleration due to gravity derivation. So you tell me what is the value of the m and what is the value of the r. Okay, so this is the acceleration due to gravity. So this is the acceleration due to the action of gravitational force, and this is the acceleration, right? Remember, when we are moving to downward, the sign is positive. When we are moving to upward, the sign is negative. Okay, so this is about gravitational force. If you didn't understand, then please comment me. We will discuss again. Okay. Now we will see the value of the acceleration due to gravity at a certain height h. That also a long time question you can understand. We will see what will be the value of the acceleration due to gravity. Okay, remember how we find the acceleration due to gravity. The value is 9.8 meter per second square. So we discuss the case when the object is situated on the earth surface. Okay, so it is not at a height or it is not at a depth. The object is, that means we the object are sitting on the earth surface. So g on earth surface, not at a height, g on earth surface is 9.8 meter per second square. अर्थ सरफेस रे जीरो वैल्यू होची 9.8 मीटर पर सेकंड स्क्वायर. किंतु आमे जेतबेले किछि हाइट को पळेबा त माने आमे जेतबेले गोटे एरोप्लेन रे बसिथिबा तो सेही क्षेत्र रे व्हाट विल बी द वैल्यू ऑफ द एक्सेलरेशन ड्यू टू ग्रेविटी. दैट मींस यू डिस्कस दिस केस दैट दिस इज योर अर्थ. ओके, सो अर्थ मास इज m, कैपिटल M, and radius is r. Suppose the object is here which mass is m and it is situated at a height h. Okay, तो हम कौन देखिले ना गोटे ऑब्जेक्ट अछि तार मास होची स्मॉल m आ से अर्थ रो सरफेस रो h हाइट ऊपर अछि आ अर्थ रो मास केते कैपिटल M, रेडियस केते कैपिटल R. ओके, सो लेट अस कंसीडर an object which has mass m is situated at a height h from the earth surface. Let full stop, let capital M be the mass of the earth, let capital R be the radius of the earth. Okay, up to this. So now let make a sphere to this small earth considering R. Okay, तो आमे याकू नहीं कि गोटे spherical object तैयार कले. So what will be the radius here? So this radius that will be r plus h. So remember, so now okay, the object is in the rest position. Okay, the object is in the rest position. So object is in rest position. So what will be happening here? So remember the gravitational force and our weight force. Okay, so we will look to the situation when the object is in moving to downward. Okay, so we'll discuss that one. So I am taking to this one that this is the case when the mass is in here and this height is h. Okay, so what's happening here? So remember, in this case your weight is downward and your gravitational force is upward. Okay, so here also same case. That means the weight minus Fg, the gravitational will be 0. So always weight is equal to the gravitational force. If you didn't understood these things, if you didn't understand these things, then you can comment in the comment section. I will explain you correctly. Okay. So in this case also, if you look to the g value at a height s, this is more upward direction, so that value will be, weight will be negative, minus negative plus gravitation. And if you look to this case, these two cases are similar, but you can correctly understood to such case. This case you can correctly understood that the weight is to downward and the gravitational force is towards the central distance. Okay, that means towards the center. Okay, remember in this case the central distance is r plus h. So this is the central distance. Okay, so you first of all write, let us consider an object which has mass m, is situated at a height h. Okay, so let now full stop, capital M with the mass of the r, capital R is the radius of r. So here the central distance, okay, this is the center and this is the center. So what is the central distance? Now r plus h. So r plus h is the central distance. So now you apply the mathematics. So this is in rest position. When it will rest position, the weight and the gravitational force will be equal. So what is the value of W? So that is mg. And what is the gravitational force? This is g small m capital M divided by r plus h square. Why I am writing r plus h square? Because what is the expression of gravitational force? G m1 m2 divided by r square. And what is the r? R is the central distance. This is not the radius of the earth. When it is in the surface, then that will be the radius of the earth. But it is at a height. So in the general case, the central distance between them is the r. Okay, r is the central distance between them. So in this case, the central distance is r plus h. Correct? So cancel. So that g will be gm divided by r plus h whole square. Okay, so now compare this to your earth surface system. Compare this to the earth system. So what's happening when the object is in the earth surface? Okay, so compare to object on earth surface. So earth surface रे जेतबेले ऑब्जेक्ट टा रहउचे सेतबेले कोन होउचे ना हमें या टिके पूर्वरु देखिले जे g रो वैल्यू होउचे gm/r², राइट? सो g रो वैल्यू होउचे gm/r². किंतु ए g टा को वैल्यू जेतबेले अर्थ रो सरफेस रे रहउचे. ओके, तेनु सेति पई हमें ए g रो ना कोन दबा g डैश. ओके, ए g डैश के जेतबेले अर्थ रो गोटे हाइट रे ऑब्जेक्ट टा रहउचे सेतबेले एठी जो एक्सेलरेशन ड्यू टू ग्रेविटी पडुची तार वैल्यू हैला g डैश. ओके, एठी भी एक्सेलरेशन ड्यू टू ग्रेविटी पडुची किंतु ये तळकू आसी पारु नाही ड्यू टू द एक्शन ऑफ वेट फोर्स. Okay, due to the action of force. You consider this case, that is the object is hanged झूली की अच्छी at a height h रे. तो ये झूली की अच्छी तळकू तेनु ये तळकू खसी पडु नाही ड्यू टू द एक्शन ऑफ द ग्रेविटेशनल फोर्स. सो एठी दुईटा केस रहउची, ऊपर रहउची न नाही तळे रहउची किंतु ओटा हाइट रे रहउची. ओके, जदि ऊपर रहउची ताले वेट टा नेगेटिव, जदि तळे रहउची ताले वेट टा पॉजिटिव. ओके, तो से केस हम देखिबा वेट ग्रेविटेशनल फोर्स सहित समान. तो हमें जानिने जे एई जगह रे g रो वैल्यू केते, तेना हमें सेटा नीचे g डैश. ओके, सो w इक्वल टू mg डैश जोटा ला ग्रेविटेशनल फोर्स सहित इक्विवेलेंट. आ हमें एई केसटा को देखुचे या सहित कंपेयर करूचे. ओके, सो व्हाट विल बी g डैश? What is the value of gm? So gm is nothing but gr². So this is gr² divided by r plus h whole square. Okay, so you do the mathematics, take the r² to denominator, so that will be g dash equal to g divided by 1 plus s by r, that is square. So if we will take it to numerator, then that value will be g into 1 plus h by r all to the power minus 2. So if we will do the mathematics, then that will be g dash equal to g into 1 minus 2h by r. So this is the acceleration due to gravity at a height h. So g dash equal to g into 1 minus 2h by r. What is g dash? This is the acceleration due to gravity at a height h. And what is h? The height h. And what is r? R is the radius of the sphere. Okay. R is the radius of the earth. Okay. R is the radius of the earth. H is the height at which the object is situated, and g is the acceleration due to gravity on the earth surface. आमे ए सिचुएशन को या सहित कंपेयर करछे. So g dash equal to g into 1 minus 2h by r. तो एटा केमिति होला ए minus 2 टा एठी गुणी होई जाय when h is very less than r. बुझि पाला. So ए minus 2 टा एठी मल्टीप्लाई होई जाय. एठी प्लस साइन अछि तो minus 2 टा एठी मल्टीप्लाई होई जाय. तो जी वीडियो to बुझि पाना, on which step you didn't understand, please comment. I will explain again this case. So that minus 2 will be multiplied here when h is very less than r. आमे जानि छे जे r रो रेडियस टा होची बहुत बडो. आमे जदि r रो रेडियस टू बेसी हाइट को पळेबा ए एक्सेलरेशन ड्यू टू ग्रेविटी ही 0 हो जिवो. हला ओके. सो दैट विल बी नेगेटिव इफेक्ट पड़िबो नाही. तेनो आमे अति बेसी रे जितके भी हाइट जीवा सेटा अर्थ रेडियस टा कम. So h is very less than r. This is practically possible. h is very less than r because 6400 kilometer. The value of r is 6400 kilometer. 6400 kilometer radius होची. तो हमरो पाखापाखि 1600 किलोमीटर पर्यंत ग्रेविटेशनल पुल रहूची. तेनु ता आगु तो हम जाई परिबनी. So this is less than r. So just less than r होचे a minus 2 टा it multiply हो जाए. So again I am explaining g dash is the acceleration due to gravity when the object is situated at a height h. Okay, and g when the object is on the earth surface. Earth surface रे जतरा रहउचे value g, height रे रहले g dash, r होचे radius of the earth. So this is the expression of the acceleration due to gravity at a height h. So remember these things. And what are the h, what are r? R is the radius of the sphere and h is at a height which it is situated. Remember this equation is always, you have to remember, this is always correct. Okay, weight gravitational balance. Okay, so we'll stop here. If you didn't understand, then please comment and share this to your friends, colleges and every family members also who want to study it and want to explain it. If you didn't understand if in any step, then please comment. I will explain correct. And I have my number also given. You can message me if you have any doubt. Then in the next class, we will see further and we will do the problems. Thank you.